So the second part of the fundamental theorem of calculus talks about the area function, and the area function is assigned area from a to x under a curve. So we're going to define the area function to be the integral from a constant a up to a variable x of some function with respect to t, which is the assigned area from a to x of a function of t. Ultimately, area function is the antiderivative on the interval, and that the derivative of area of x is equal to f of x. So if we look at this particular example, and we want to take the integral from 1 to x of t dt, we know the antiderivative is t squared over 2, but now we're going to evaluate it from 1 to x. So then we can substitute in x squared all over 2 minus 1/2. So this then gives us the area function under the curve. So now we're going to look at how to differentiate a function that has an integral in it. So, for instance, if we want to differentiate a function g of x, where we have it from a constant up to a function little g of x, we're going to let g of x equal the area function of the little function, g of x. So we're going to use the chain rule, and we're going to look at this example to show how this can be done. So by using the chain rule, we can look at this and break it down as follows. If we're trying to find the derivative of the integral of cos of x, or sorry, negative 6 to cos x of u to the 4th du, we can set our a of x to be the integral from, in this case, negative 6 to x of u4 du. A of little g is going to be the integral from negative 6 of cos x, g of x I should say, of u to the 4 du, where g of x is now equal to our cos of x. And we're going to set our big G of x to be equal to your a of x with little g of x inside. The derivative then, which is what we're trying to find for this question, is then going to be using the chain rule. So our big G of x, our derivative, this whole entire function, what we're trying to figure out, is then going to be the a prime of cos of x multiplied by the derivative of cos of x, which is negative sine x. And because it's the derivative of the antiderivative of the integral, it ultimately ends up being the overarching function of u to the 4. So you're going to get cos to the 4 x times by negative sine of x, which is the same thing as negative sine x cos 4x. Just going alphabetically with the sign in front. Now another way to look at this as well is to take the antiderivative, evaluate from negative 6 to cos of x, and then take the derivative of this. So that you plug in your cos of x and your negative 6 to the 5th, take the derivative of this entire thing. By doing that, derivative of a constant will disappear. Cosine 5th of x over 5, we can set up our derivatives. This will work out to this. The 5's will cross out, and you'll get the same thing. And again, alphabetically, sine x cos